Okay. Okay. Welcome, everybody. My name is Doug Purnell. I'm one of the co-leaders for the Triad Microsoft Data Platform User Group. Myself and George Maxson help run this group, and we've been virtual, as you can imagine, for the last few years, and it's been going well. We've been able to get a lot of great speakers like tonight as well with John. So with that, we are part of the Azure data community. There's a lot of other user groups, and they do a lot of great things for us. It's part of Microsoft, and so something to keep in mind if you're looking for other user groups. Most of them are still doing virtual, but slowly you're starting to see more in-person events. So it's good news. Speaking of which, these are the upcoming SQL Saturday events that are coming around. So I know Jacksonville and Jersey, everyone's starting to submit for those. Those are, as far as I know, those are all in person. And then if you're out of the country, Haiti and Nepal are coming up. So yeah, this is good to see. And then as well, some of the other events happening, Data Saturday events, Visual Studio Live, Toboggan, Data Toboggan, and Visual Studio Live. So a lot of great stuff. I'm glad things are starting to open back up again. It makes learning a lot more dynamic. For those of you that are familiar with the old PASS organization that Redgate has sort of taken over, all of the past summit videos are on the PASS TV channel on YouTube. So a lot of great material. As you're aware, a lot of the core functions of the engine really haven't changed a whole lot. And so a lot of the videos are still work today, even though we're on 2019, soon to be 2022. So if you're looking for something, you might find it out there. I'll be sharing this slide deck as well, but we have a user group we have our videos being recorded as well onto YouTube. So you'll see this posted in a few days, and I'll share a link inside of Meetup once I get everything published. There was at one point a PASS Pro membership, and those videos are still available. They're underneath the educational series here, right in the center. There's 4 courses. These are all available for free. If you're interested, there's still some good content. Some of the folks from Danny Cherry and Associates recorded some, and a few others as well. So if you're interested in that, give that a listen. And with that, I'll get things pushed over to John Miner. He's going to talk to us about data engineering with Spark. So
Excellent.
Let me start sharing. And
okay.
Let me get
Yep, I'll share in a minute. Say hi to everyone. Hello. I'm going to probably hide my screen so that hopefully our video will go a little faster. A little about myself, just like Doug, I run the SQL user group up in Rhode Island, more like a data platform group, user group now, because I've been doing it for X number of years. Hosts disabled participant screen sharing. So you need to make me a presenter.
Oh, I think just a second.
No worries. It's always these little fun things. I'm going to stop my video. Right. Let's try it again. Nope. Tell me when you think I have it.
Okay, try it now.
Okay, perfect. And I'm just going to do my main screen. Okay, hopefully everyone can see what I'm showing.
Yes, looks good.
Awesome. So I'm going to minimize this and bring up a web browser and going to show you a couple of links, okay? So the first thing is if you go to GitHub, okay, and you type John Miner, okay, you can pretty much see what I've done for the user group over the last, or community over the last 10 years, right? And what we're going to do is we're going to be talking about, this is just a little tweak of transition your T-SQL skills to Spark. I can put the slide deck out, but basically here it is. What is ADB? Well, that's Azure Databricks code samples. And if you go in here, there is 2 types of books. There's something called the IPY notebook, and that is a Jupyter notebook. Okay, so interactive Python, and there's also a PY. If you click a PY, it'll kind of show you what the code is. So you got all the code that we're going to talk about today. Next thing I want to share with you, a couple things, and then we'll get on to the actual presentation. If you type John Miner and an MS SQL Tips, I've been writing for MS SQL Tips for, God, 7, 8 years now, pretty much putting out a single article per month. Okay, interesting thing we're going to be talking about today is Apache Spark, and I have one that's really geared to what we're talking, which is data engineering. So if you're interested in it, it goes over a lot of stuff we have, reinforces it, okay? Maybe a little, twist on what I'm talking about. And that's about it. So I'm going to go back to the PowerPoint and we'll get into the topic. So I'm going to hide the presentation view. Okay, excellent. So how I'm going to break this up. First, I got to talk to you about some foundational stuff, and then we're going to do some hands-on stuff. I'm going to mix it in between. I'm going to pause after talking about the foundational stuff and for each section. And if you have any questions, that's the time to ask it. If not, please wait until I'm done like the demo and you can ask again. Okay. So again, my name's John Miner. I've been a data architect at Insight Digital Innovations for 4.5 years. I'm also MVP, hopefully getting my 7th award this year. And like I said, I've been very active since Grant Fritchie, who was the past president of PASS, introduced me to PASS back in, 2009. So it's been a long time. We're going to be talking about engineering with Spark, okay? So why do we want to talk about Spark? Well, many companies are moving their workloads from on-premise, okay, operational data stores to in-cloud data lakes, okay? And if you're going to do data lake, oops, sorry, someone.
Oh, yeah, let me
Mute everyone, please.
Yeah, sorry.
Awesome, no worries. So many companies are moving their loads from on-premise operational data stores to in-cloud data lakes. So there's only a couple of players out there, okay, to actually manipulate data. You can use Spark, okay? You can also use something, say, like mapping data flows, right? But guess what? Mapping data flows under the hood is running Databricks, so it is Spark anyways, right? Or you could do wrangling data flows, and guess what? That engine translates it to Spark. So in general, you're one way or another, you're going to be using Spark if you're going to be playing with a data lake. As a developer, I've been, learning and teaching, SQL, and should I say more like teaching SQL for pretty much the last 10 years. I was introduced to it in probably 1989 when it was SQL on a mainframe. Okay, so it's been a long time. But guess what? Those SQL skills can be taken advantage if you just know a smackling or a sparkling of Python. We just a little code, and guess what? Your SQL skills will be right there, and you can actually take advantage of them. And that's what we're going to talk about today. We're also going to talk to you about the concepts and code that will help you during this transition. So if you want to transition from a SQL developer to say, hey, I want to work on a big data team and do Spark, then you definitely can do that. So what's the topics? There's 4 main topics, and I put these icons here that kind of like represent them, right? So what's the Spark ecosystem? So we got this Apache Spark icon. Okay, regardless of where we are, we have to do storage management, right? So you got the cloud and you got this little box underneath. That's your storage management, right? Then how do we do data engineering, okay? So one of the things you're going to do with data engineering, you're actually going to go ahead and we're going to use PySpark, okay? So that's Python calling the Spark engine. And then last but not least, no one really wants to work with files. I mean, I started working with files in 1991 when my first job. It was quick basic using Microsoft, right? And we read files from DOS and wrote them back. You don't want to work with files. We want to do tables, right? So we're going to talk about the Hive and how we can present things as tables. So Spark ecosystem, we're going to have 4 different things we want to talk about. We want to talk about the various components. We're going to talk about cluster management. We're going to be talking about how do you organize your notebooks, right? And there's different places you can put notebooks in Databricks. And we're going to talk about scheduling your action with jobs, okay? In this presentation, I'm talking about Databricks, but a lot of the code that we're going to be talking about or sharing here is just straight Spark code, so it could run on anything. So it could be native Spark, it could be, anything that you figure like Synapse engine, Spark. So it depends on where you want to write your notebook, okay? So let's talk about what is Spark, okay? So this is another diagram from Databricks, and basically it's 4 different components, okay? But they all run in one ecosystem. And Databricks, and what it does really well is combine them with Jupyter notebooks that the interface is really, really easy to use, okay? And when I first looked at it, I was like, oh my God, I think I was exposed to this in like 2018. But then when I got my first project in 2019, and I've been doing it 2+ years straight, it's no biggie, okay? Let's talk about each of the 4 little boxes here. So what is SQL and data frames? Well, again, like I said, most processing is done with files. So we need to read a file up, okay? So we're gonna use Spark, okay? PySpark, right? And we're gonna find the file on the, data store, okay? Your volume, right? And you're gonna read it into a data frame. What is a data frame? Well, a data frame is pretty much like a table, okay? It has columns. Each column is an entity, has properties, and you can manipulate it, okay? You can also expose data frames as a table and use SQL on them, okay? And we'll talk about that. And then you can read and write back. So again, you want data processing is read something in memory, manipulate it, write it back out, okay? So that's the first block in here. But there's a lot more you can do with Spark other than just data engineering, which we're gonna talk about tonight. There's things that most of the things that you do in data engineering usually considered back in the old days when I was like on a mainframe. Hey, it's batch, right? You got DB2 and you run a program, it's batch processing. Well, guess what? We have streaming also. Streaming means that we have these Internet of Things, right? Maybe a sensor that's connected to the internet and it's just sending telemetry, okay, to a event hub. So how do we capture that data in real time, write it to a data lake and do something with it, okay? And Spark allows you to do that. 2 other problems you can solve is the graph problem. So say if I want to take a trip and visit Doug, okay, down in North Carolina, I might figure out there's a couple people I might want to see. I have a friend named Sebastian, and he lives in Jersey City. I have another friend, say Dan Clark, he lives in Pennsylvania. Which way is the best way down that's most cost effective? Maybe I could do that with a graph model, right? And again, a graph is just putting a weighted directed graph, and then you can figure out, traveling problem, okay? Machine learning is the last aspect that Spark can solve. We're not going to talk about that tonight, but it can solve the typical 4 questions like, can you predict something, right? Can you cluster it? So which one looks the same, right? Is it an anomaly, okay? And those are the type of problems that machine learning can talk about. But again, we're going to be focusing on this top left-hand corner over here, which is SQL data frames. So a lot of these technologies that you hear, say Spark, some of the MPPs like Snowflake, okay, they all are based upon distributed processing. So you have a single node, a driver node, and it takes a unit of work and it has to give it to a bunch of executor nodes, which is a child. So it's a parent-child relationship, right? One thing I want to point out here is if you look at these boxes, there's a little JVM assigned to each of the boxes, okay? That means it's running on a Java virtual machine, okay? And by creating tasks, the driver basically says, hey, I got some work, where can I assign it to, okay? Now, this is where petitioning is really important because this one, if you look at this example, maybe you have 2 jobs. Maybe one job's running as a petitioner 1 and it's running on the second executor. And they have another job that is petitioned into 4 pieces of files, right? And that's running on executor 1 and 4, okay? And this would actually show you the exact, picture of how it would be running because each of these would be some type of thread or CPU it could run on, and that's called a slot, okay? Okay, just like SQL Server, okay, Databricks has something called an optimizer, and it basically has to take the code that you have and come up with something that can run on a JVM, Java Virtual Machine, okay? Kind of complicated, and this is the secret sauce that makes the difference between open source Spark and other platforms like Databricks or Synapse, okay? Again, looking at the input, it could be a Spark SQL statement. It could be a data frame. What's the difference between data frame and data sets? Well, Spark is written on, a language called Scala. Now, what is Scala? Scala is object-oriented Java. So object-oriented languages are very type safe. So that's why they call it a data set, because it's very type friendly. It means that you have to know the type ahead of time before defining it, okay? Data frames, especially in Python, is just the opposite. It's type free, right? It doesn't really care as long as you define something, and there's only a few types that you can have, and it doesn't really matter. How does it go through this process? It takes that plan that you give it. It has to say, hey, is it something that's in the Hive catalog? If so, I know where to get it. If not, is it something from file, right? Create a logical plan. Let's optimize it to a physical plan. Does some type of quest modeling. And then what does it actually generate some code, okay? Java bytecode. Now, that's what gets executed on the cluster. And there might be multiple phases, okay, of steps that get executed, okay? Now, last but not least, what is an RDD? Well, this is what makes, okay, Spark a lot faster than Hadoop, okay? Back in the day, and again, Doug could probably tell you, if you went to, the past back in, convention back in the 2014, 2015, you might have heard of Hadoop, right? And they had the pink elephant and they were going over there and the big thing is that it ran, but it took forever. And why did it take forever? Because it read from disk, HDFS, which is the Hadoop file system, okay? And it wrote back to disk, okay? But it had to do that between every step. So it was really slow, right? What's the good thing about Spark? It's all in memory, right? So it's just Java code, but it's writing in memory. And what's an RDD? It's basically a resilient distributed data set, okay? And it's immutable. So if I read, say, a bunch of salaries up from Elon University, right? I could read that up into one RDD. Now, say the university was great and they were doing really well, so they want to give everyone a 5% bonus, okay? And they're going to change your pay by 5%. So we're going to say salaries equal to salary times 1.05. That makes our update. Does that happen to the first RDD? No, because that is immutable. You can't change it. So it makes a copy of it. It's the second RDD. And because a write operation does not make any changes, it just writes it out. So that's how RDDs work under the hood. A lot of this you don't really need to know, but it's good to understand. And there's plenty of books out there to read on more on how the Spark engine works. So let's talk about interactive job versus pool and cluster, okay? Well, Databricks, okay, when you start it up, okay, you have to have something to run on, okay, that cluster, okay? So you have to stop a cluster. And it allows you to schedule the engineering job or notebook to run at a given time, okay? Now, say if I was designing something right now and I wanted to ad hoc run the report one time or repeat it, okay, then that's an interactive cluster, okay? A job cluster, on the other hand, is something that I schedule, okay? And so we can see both of them right here. There's the automated job. And the interesting thing is that if you are setting up stuff, you want to use a pool. And what does a pool do? It allows you to keep a warm cluster around. So when we go ahead and we say, hey, and why this says cloud provider? Because Databricks is agnostic when it comes to clouds, okay? It could be GCP, it could be AWS, could be Azure, it does not matter, okay? So if you had to go right to the cloud and you didn't have this pool in place, it would be really slow. But if we had the time to live for the Databricks pool to say be an hour, and we run a job every 20 minutes, guess what? We would never have to start up the VMs from scratch, okay? They would always be sitting there warm in the Databricks pool, okay? So that's the biggest thing. You have both interactive jobs, that's how you develop code and run code manually, and automated jobs, and those are things that are scheduled. They can either be scheduled within Databricks as a job, or a lot of times many people use Azure Data Factory to actually schedule jobs. Okay. So let's take a little break and I'm going to show you a little about Databricks and then we'll get into storage management, okay? So I'm gonna minimize this, I'm gonna close this, I'm gonna close this, okay? And I'm gonna go to here and I'm gonna go up one. Okay, I got a dashboard and this is when I talk to users or user groups. This is where, I have two different clusters, one, some work for work. This is my demo cluster. I got a storage count. So the interesting thing is Databricks has some storage itself, and we can see this is the Databricks right here. This is the resource group that it creates. So it has a storage count, has a network security group, and it has a VNet, okay? The interesting thing is you do not, this is a managed service, okay? So you don't have any access to this. I'll show you that in a minute. Under the storage count here, we have full access, okay? Because I described and created the storage count. I created a container. I signed permissions so I can go into this. This is a storage container inside here. I got different things like SQL Saturday, a silver zone, a test zone, a gold. We got different things, right? I'm breaking it up. Typically, when you talk with Data Lake, we talk about bronze, silver, and gold, and we'll talk about that pretty soon in more detail. But I just wanted to show you the components. One of the good practices or best practices to go ahead is to use Data Lake storage separate from Databricks, because Databricks has limited storage. Second, which is another best practice, is if you're using any type of credential or keys like a username and password, put it in a key vault because you can pull from it, and that can be backed by a scope, okay, a Databricks scope, and that's their version of the, their security system or keys. Now, going back to this resource group, the interesting thing is I know I have a cluster spun up because before this, I actually started a cluster, and we can see it's a cluster that has 3 nodes, okay? Well, if we go here, remember I told you that clusters are nothing but VMs? Well, we see a VNet. We have the storage. We don't see anything yet, okay, about the virtual machines, but I'll show you in a minute. Now, I just went into the storage count. Unlike the other one, if I go to try to get in here, I see, oh yeah, there's a root directory. Maybe that's the root of the storage for Databricks. I want to look at it. And guess what? We have no access to it because it's a managed service, okay? So again, we really can't do much with it other than a couple little tweaks here and there for security. So most of this stuff is managed, just leave it alone. One of the things we can do is hit refresh. And now we see, guess what? There's a ton of stuff here. That's because we have right now running 3 nodes, and we can see that it actually instantiated 3 virtual machines. So if we sort by type, and we go down, we can see that as a virtual network, and there's 3 virtual machines. And if we click in it and we take a look, it's running Ubuntu, okay, Linux. So again, it's a JVM under Linux, okay? So let's look at the Databricks interface and we'll get into it a little. So one of the things I talked about is jobs. Well, this is where you can create a job, and we'll get more into that pretty soon. We talked about Hive. This is where Hive is. So this is if we had data published, we can see it in here. We do have some, okay? This is the recent files if you worked on anything. Hey, I was playing around with storage management. If I connected it to, say, a repository like GitHub, okay, I could say, hey, it's connected, and we could check things in and out. And we have a workspace. So the workspace is where most people work. And there's 2 ways you can store stuff. You can store stuff by folders, and it's shared, okay, or you can go by user. So I am creating, Crafty DBA is my handle, so it's there. I also read Scott Adams back in the day, so Dilbert, Dogbert, whatever, could be users, okay. And if I was on Crafty DBA, maybe I have some, sampler programs. So, and if you ever been used to actually, what do you call it? Jupyter notebooks. This is basically a Jupyter notebook. Now, if I want to try run this, it wouldn't do anything because it can't run, but we need compute. So if we go here, we track down to the cluster I have, I click on the cell, and then I hit run. Okay, it tells to run. Now, the interesting thing is that this is a Python one, but there's different languages we can run, right? We can do R, we can do SQL, we can do Scala, so on. For instance, if I wanted to go ahead and use a magic command. Now, this is print hello world, print hi Christian. I can set X equal to John and then print X, and I'll get John come out. Okay, so this is all interactive. Last but not least, I can use something called the magic command, and I can switch between different languages. Even though it says it's Python, instantiating a variable in Scala is totally different. It's type safe, so I have to say it's var y is equal to Christian. And if we run this, it'll run it in Scala, okay? Now, the interesting thing, last but not least, is it tells you how long it takes, who ran it, and when. For longer jobs, it tells you how it actually decided to run on a cluster, okay? So I'm going to minimize this, go back to the slide deck, and continue. Is there any questions? Okay, if I don't hear from anyone, then there's no questions.
Yes, I do have a question.
Sure, go ahead.
What are the dependencies before we get to this stage? What libraries or things we need to install?
You do not need to install anything. That's the cool thing about it. It's a managed service. It's all there. If you want to extend it, I'll show you once we get into clusters how to extend it. Say if you had a library, like I had one client, which was a US government, we were bidding for something. They had satellite data and it uses something called a 2-line satellite thing. And so again, remember that anything that doesn't say Spark dot, it's not developed for distributed processing. Okay, it means it works, but it won't go on and use all the nodes. It'll run at the head nodes. But for this case, we had a file. Okay, we need to get into a data frame and then break it up and read into other, like say a Delta table or a Delta file. And to read that up, instead of writing code to say, okay, read everything up as text, group it by first line is 1, second line's 2, count them that way, and then take line 1 and line 2 for unique ID 1 and pen them together and then store it. I already had a library, right? And you can install libraries into the cluster. So when it starts up, the libraries are there. But in general, most users don't do that. Out of the box, the system works without any modification. Okay, so storage management. We're going to talk about mounts, folders, and files. Okay, so again, it's Unix. So you're going to mount the storage, which would be remote storage. It could be an S3 bucket in AWS. It could be blob storage. I suggest doing Azure Data Lake storage because it has RBAC, which is role-based access security controls. Okay, so it means I can be a contributor, I can be an owner, I could be a reader. It also has ACLs, which is access control list, right? So execute, read, and write. We're going to talk about reading and writing with files. We're going to talk about what's the difference between that and reading faster with schemas. And we're going to talk about supported file formats. Okay. So out of the box, there's the Databricks file system. And everyone calls it DBFS. Okay, just like there's HDFS, and it is based on HDFS most likely because when you append to Azure Data Lake storage, it's compliant with HDFS. But there's 2 places you can store things. There's a local file system and there's a remote file system. Okay. Now the remote storage can be either attached to, mounted, or attached to at runtime. Okay. I suggest mounting it, and the reason why is those libraries you were talking about, how to extend the cluster. Okay. A lot of them are only available if it looks like it's a directory. On the other hand, attaching to, and what you're doing is you set in Spark sessions variables, and Databricks is smart enough to say, hey, do a pass through. I'm going to go to Azure Databricks storage and go ahead and do what I want to do. Now, if you look at the example, there's 4 different ways to actually manipulate files or work with folders. First one is called dbutils.fs.ls. Why did I start with that? It's a built-in library that Databricks wrote, and dbutils has a bunch of them. FS means file system, ls means list. I'm going to show you the temp directory. Now, remember I talked about magic commands, anything that starts with %s. %fs means it's a file system. Same thing, ls temp. The only difference is between these, the output might be different. One might be text, one might be objects, okay? To the right over here, we see some more traditional older stuff, right? We got import OS list directory. That's an actual call to a Python library, the OS library. We have sh, which is a shell script. Same thing, ls. Now, some of these, depending upon what language and technique you're using, some you might have to append dbfs, like the 2 on the left versus on the, I meant on the right. On the 2 on the left, you don't have to append anything, which is kind of cool. Let's talk about quality and zones, okay? So if you are managing a data lake, the first thing is that you definitely want to have some type of lineage, how things are getting put into the data lake. So it's really good to have auditing. Second thing is name conventions are really important, right? Bronze, silver, and gold is what most people that work with data lake break it into, okay? Bronze is where the raw stuff comes in, okay? So I got a file. Let me use AdventureWorks as an example. So I got a file that comes in and it has new addresses for customers. So it's a brand new, what we sold to today. And we're using a data lake to do single glass, pane of glass reporting, okay? So I get a file in and I start into the bronze layer, okay? It's raw. But I know that I have problems with the files that people do data entry because sometimes they misfinger something. So I want to run it through a program that has a bunch of zip codes. I look it up and I get zip +4. I can also check it by state, right? So what we do is after we have it in bronze, we might write a program to read up the daily file, compare it to this lookup file or some type of service, get a cleaned up file and save it into silver, okay? And the silver zone sometimes is called refined. So you can, again, raw for bronze, refined for silver. Now, say at that point, I also have the daily sales, right? And so basically I want a shipping report in gold. So maybe I'll say, hey, this is what is shipping today and here are the addresses. So I'll join those two, okay, in silver and come out with a gold. This is where we can go ahead and do data and AI. So we can say how many, what's the chances of this person maybe defaulting on paying, or maybe, report how many are going out to Rhode Island versus how many go in North Carolina. That's the type of thing. Again, the quality from left to right goes higher. Two different things here also. If you ever heard of Lambda, okay, architecture, Lambda has something called a fast lane and a slow lane. Slow lane is batch, runs like once a night. Fast lane streaming, it means it runs all the time, real time. You can run batch to be near real time by setting the schedule to be tighter, meaning every 5 minutes, it's near real time, good enough for maybe my user, or maybe every 15 minutes is good enough again. This is all subjective and there's no fast rule of what you need to put in bronze, silver, or gold. Okay. So managing mount files and folders. I suggest using the Databricks library to create, copy, rename, delete both files and folders. Databricks supports both session level and service level connection to storage. That means versus session is the attaching versus service is mounting. Once it's mounted, it will pretty much stay mounted. Okay. And this will allow all those non-Spark libraries to work. So what we're going to do is we're going to look at examples 1 and 2. What's an advanced topic that I suggest you to look up if you wanted to learn more about how the Key Vault back secret scope is implemented. At the end, you can look at some references and just look it up. It's pretty easy. Okay, so what we're going to do is we're going to go to Workspace. We're going to go back up from users to shared. Okay, and this talk is practical data engineering. We're talking about the very first topic, which is mounting storage, okay? Storage management. One cool things you can do again is this is a markdown MD. And MD is a special magic command that allows you to put a file in. So I've been writing as the crafty DBA for a long time. And this is my avatar. Also, we can change the font, and this is what we're going to be talking about. Library versus magic commands. We're going to work with directories, create, delete, copy, rename. Work with files, create, delete, copy, rename. And we're going to talk about local versus remote, okay? So if we did fs help right now, it would show you all the different things we can do. Okay, and we're going to stop playing with them. So this is one way to call help with a magic command. We can also db utils.fs.help and you get the same type of results, okay? So let's do our first command. The other ones I've shown you, if you do the shift key and enter, it actually runs the cell, okay? So now we run this and basically it's going to show you the paths, okay? So it is dbfs. File store is the way you get it by default. That's where everything goes in. So if I uploaded a file manually, it'd go in file store. I can also, so this one you can see, this is actually kind of returning a grid, okay, a data frame, okay. When it's a grid like this, we can do things like charting. Doesn't make sense maybe, but let's chart like, I don't know, size, right? So we can do a histogram and see this kind of weird. We can go plot options, right? And we can take modification time out. I can just put down, I don't know, put the name in and we'll bring size in. And then obviously it probably doesn't even make sense. And we hit apply and we get gobbledygook because we don't really have any good data. If I go back to the grid, it brings back the grid, okay? So that's one way it can display. Another way is if we do db-utils-fs, we can see this is actually coming back with what? It's a Python object, right? And so this brackets is a dictionary and it's a dictionary object and each object has a path, a name, and a size. So one of the things we want to do is we can create a sample data lake. So this code right here, 3.1, is first going to do a try. And it's going to try to remove the data lake. And recurse means remove everything underneath it. Then it's going to create the lake, the bronze, the silver, gold, and then it's going to ls the lake. Okay. So if we copy this one thing right here, and maybe I have it down here, I can just change this a little, put it here, and we do it. We can see that there's nothing near it, right? There's a bronze directory, there's no silver, there's no gold, right? And so what we can do now is we'll run this and we'll suddenly have those other directories. So we're going to run this. Okay, and now it created those. And now if we run this, we can see it has all three. Okay, so I'm going to get rid of this, confirm. Okay, so when I go back all the way up to here, we saw these directories. One of the directories is called Databricks.datasets. Databricks knows that you're going to be learning how to use Spark, and so they give you a bunch of data sets to play with. So we're going to work with them. Okay. Very first one is the power plant data set. So if we do the same thing, dbutils fsls, it's going to come back. You can see there's a README file, and we can also see there is a data directory. Okay. How can we read the README file? The dbutils fs head will give me the first 500 bytes. Maybe that's not enough. Maybe I want the first 1,000. So I'm going to change my program, just hit it. And now it should run and it should bring me 1,000 lines. So now we can see it's a little bigger. Okay. It's cut off though, because it's not all the way. We can go and do ls on the data. We see that there's tab separated values and there's actually 5 files, 1, 2, 3, 4, 5. Okay. And what we can do is we can pick one of the files and say, give me the first 500 bytes. And again, it's going to show us some data and we can see that we have at the top tabs, and this looks like a header line, right? And a carriage return. There's no such thing as carriage return line feeds in Unix. And then so on, it repeats over and over again. And so we can also, if we want to manually do stuff, we can put something. So we could say insight hello world, this is my first program, and I can write something out to hello world. And we can say, is it there? And we can say, yep, it's sure there. And we can remove the file because it's just a play file. So boom, it's gone. We can also write to storage using Python, right? So path equals where we want to go, open it. This is why you want to use mounted versus pass through. Write it and then close it. And so this is going to write my first program. Okay. We can also look into the top directory. So we can glob data lake, mount, and show me what's there, right? And we can see, hey, guess what? I wrote it to the data lake, which is a mount, and I see hello world, right? We can also traverse directories. So if we wanted to, we could say print the files in the bronze zone. And if we run this, we can see the outputs here. Okay, so, and we can also say, hey, guess what? Back here, this one says OS work, but we're actually looking for the directories, okay? And we can see, okay, those are the files in the directories and these are the subdirectories, okay? So we can use a lot of different commands that are native to Python. We can also remove the file. Again, remember these native commands that are within Python do not run in a cluster, they run at the head node, the executor, okay? So let's do some work. We're gonna copy over a file. So copy files and folders. So we can see copy from here to lake data. And then we're going to copy over the README, and then we're going to look at it. We should have these files, right? And right now, again, remember, I have not done this. So if we go over here and put this here, it should be empty. And it says, hey, we don't even have anything there, right? Because I haven't made it yet. So now if we run this, and guess what? We're going to get a bunch of files. And we do. Okay. So I'm going to delete this. Okay. And we've run this, we'll be back to where it was before. And unsell should give me nothing. Used to be a clear, I don't know. Used to be a clear cell. To add a new cell between them, say I want to put a spacer, boom, just hit a button and it brings it back up, okay? I must have hit it twice, so get rid of it. Okay, so now what we can do is we can move files and folders. So if I wanted to, I could move lake to junk, and then I could move data to bronze, and then so on. So, and at the very end, we'd have bronze here, okay? So let's undo these. And Control Enter or Enter Shift, runs it. And boom, we can see we moved it. Remove, so we can say, hey, you know what? I noticed that there's a README file there. I don't want it, so I can remove it. And we can show the lake again. So I'm just showing you how to rename, move, copy. We can also go ahead and remove recursively. Okay, we can also remove just the TSVs. So if we remove the TSVs, okay, no wildcards, it doesn't like it. So it doesn't work, but we can do it this way and it works perfectly. And then if we go back to here and we run this, we can see that basically it lists everything. Okay. And these are at the root directory. Remote storage. So how do we work with remote storage? We can show the mounts by running the mount command, okay? And the mount says, hey, we got Databricks data sets. So there's a couple mount points. The one I actually did is this one. This is ABFS, which means Azure Blob File Storage System, and that's basically your Azure Data Lake Gen 2. Okay, this is your storage container. This is your storage account, and that's where it points to. And so we can go ahead and list on the data lake test. Is there something called a test directory? And there is. And what that is that's the AdventureWorks files, the Parquet files. Okay. And we can unmount it. Okay. Boom. And it unmounts the storage. So it'll take a little while. Then if we run this other test we just did, it's not going to work. And then we can remount it. And I'm going to show you how to call another program with parameters. Okay. And how that works to mount. And of course, it's going to take a little while. Okay, so it's been unmounted. So if we come back down here, we run this test, it's going to fail. Okay, so oops, does not exist. Makes sense. So what we're going to do is we're going to call parameters. We're going to pass the count name, file storage, mount point, and there's a book right here called Mount FS. We're going to call it. So DBUtils has many other things. One is notebook, and we can run it, get a return, show what return job. This is going to run a job, and we can actually see it running. Before we do that, let's take a quick peek at that file. What does it do? Oh, what's these at the top? Well, this is something called inputs parameters, okay? And they're called widgets, okay? So you can see the widget down there. And so we can define a widget, data lake, storage count, storage container. To get this, and what we have is we have the tenant ID, client ID, and password, which are real tight secrets for storage count. We don't want to give these out in our key vault. And it's a key vault backed vault scope. Okay, we read those in. Okay, and then what we do is we can actually run the code to mount it. So this is the code, does a config, and then it mounts it. If there's exception, if not, it says it's successfully mounted. So I show you the code behind it really fast. Take a look at it, learn about it if you're interested. If not, it just works, and copy and paste, and it works. Nothing to write home about. It's the normal code you'll see. It's just commented well, and it uses a key vault backed by scope, Databricks scope backed by a key vault, they call it. But it's basically a key vault. So now we can see this job's running. Well, what does that mean? Well, now we can see that it's going to spin up a job cluster. Okay. And now it's going to go ahead and run this. See, it says command submitted for cluster execution. Hopefully it reuses this cluster that I already have running. And so it did, and then it got here and it finished. See right here, it successfully mounted. So we actually saw it execute, okay? We could cancel it if we wanted to, if we didn't like the job, but I definitely like the job because that's what I wanted to do. Let's see if I can minimize this a little, close this, okay, boom. So now you have an introduction to how to manipulate folders, how to manipulate files, and how to mount storage, okay? So let's talk about some more concepts. So that was mounted there. Let's talk about various file types, okay? So various file types. There's a weak type file formats and strong type file formats, okay? So I usually try to keep my clients away from weak file formats, okay, such as a CSV. And why is it weak? It can be easily broken, okay? And there's many reasons why not to use it. For instance, you don't know what the header, the columns are, you know, of the table, okay? And two, you read up the header line, okay? Second thing is you don't know what the data types are. You have to infer them, okay? And last but not least, it doesn't support a lot of things that you want to do when you're doing distributed processing, like, hey, maybe is it splittable? Is it compressible? The nice thing about it, most people use an Apache file format. It's not the only one that Apache came out with. They have Avro, they have Orc too. Look them up. There are different cases for each. Why is Apache file format popular? Because Delta tables are built upon it, and that's why I push for it, okay? You can't break it. So there's no way someone can, like in a CSV file, if someone landed it in raw and they decided, you know, you had a hacker, you came in and maybe added an extra column, suddenly it breaks, right? In Apache, there's really no easy way to get to the binary data. You have to download it, get a plugin like VS Code to read Python, I meant Apache, go ahead, make the change, save it. You know, it's not easy to actually edit versus using a text editor. Column names, data types are there, and does compressions, it's splittable, okay? So those are the two types. How do we process files, okay? Well, weak types can take more processing because we have to infer the schema. How does Excel work when it does a CSV? It reads it up and it scans like the first 200 rows and guesses at what the data type is. So we have, say, an SSN. Is it really a numeric or is it an alphanumeric? You don't know until you read up a bunch of records. And therefore, it could error out farther down when you page into Excel because it suddenly says, oh, it thought it was a numeric, and now you find an alphanumeric, okay? Also, you have to understand when you do data process, what are you going to do with corrupt records, okay? I'm not going to talk about it tonight because we don't have enough time, but you can extract and validate, apply a schema, but you also need to handle how you do corrupt records. By default, it just stops the processing with error. Okay, so PySpark, okay, what is that? PySpark is an API for Apache Spark. It's written in Scala, but it's for Python, okay, and allows you to proj large data sets in a distributed cluster, right? The two main ones are spark.read, spark.write, okay? So example 3, we're going to talk about it. Advanced topic is data frame methods. Okay, there's a ton of data frame methods that you can use out there. Not going to get into tonight because we could spend just a whole hour talking about data frame methods. Okay, so go to Workspace and we go to read and write data sets. Okay, again, I have my thing. I have some N toolbox code. Oh, wow. So I'm going to actually bring some code in. What is that? I don't know, but let's run it. And it wants me to attach and run. And just, it's interesting. They always continuously change the interface. So some of these things are acting a little different than what I've seen in the past, which is kind of cool. Now let's look at the toolbox code. What's in here? Okay, so we have a function for get file list. Okay, we have another function called unwanted file cleanup. Okay, and that's it. I'll show you exactly why we're using those. So go back to number read and write data sets. Okay, so I'm going to run this again. It probably should be in memory, but I'll run it anyways. Okay, so what we're going to do is we're going to create a sample data lake. So we're going to get rid of it all again. So we're going to run the cell, and it's done. Now we know that Databricks has a weather data set. Okay, there's 2 files. Okay, so we can run this, and we can see there's weather, and we can see in here there's a high temps file and there is a low temps. Okay. And if we look at the low temps, we get the first 500 bytes. We can see some information here. We get the high temps. I want to join these 2 tables. How do I do it, right? Well, I'm going to put the path in Databricks dataset, weather low temps. I'm going to read it. Because it's a comma delimited file, I'm going to say that the header is there because we got date and temperature. The separator is a comma, infer the schema, and read it. So now I'm going to get my first data frame. Remember we talked about data frames, and this will be a data frame. Okay, now remember I talked about how it runs on the cluster. We can hit the job here, right? And in the job, it has stages. We can look at the stage and we can go into a visual. And it says, hey, it's doing a scan text and it's doing a whole code generation, okay? And if we really wanted to, we can see that this is what it's doing, but we can actually look at the input and output and like the notes. So let's see. That's the event timeline. Don't want to look at that. Don't want to look at this. I want to look at this, and we can see that this is basically a Java. And let's see what else is coming up. Okay, so we can see that durations, and we can see its process executor ID. Remember I told you there's an executor ID in slots. You can tell it's there, right? And we got standard out and standard error. So we can look at standard out, and we can see that there's some global allocation going on here. But we can see this is just a startup of the actual cluster. So it's not really telling us much here. But again, some of these will have more stages, right? We can go into this is stage 1, this is stage 2, and then we get a data frame, okay? Now, once we have the data frame, we can do a lot of things. Like I can go a little off script, but I can hit display, right? And then I can do the F1 and hit enter. And guess what? Should show me this data frame, right? It's taking a little longer. Now we can see our data frame. So now we got a date and we got a temperature, okay? So I'm gonna close this. I wanna join the two, right? So what I'm gonna do is I'm gonna rename the column temp to low temp. So I'm saying data frame 1 is equal to data frame. And this is manipulating the data frame with data frame, methods, okay? I can also show the top 5. And it's gonna show me in there. Boom. I'm gonna read high temps in the same way I did low temps, okay? So I'm gonna go here, hit temperature. I read it in. Now this time I'm going to rename temp to high temp and date to date 2, because we can't have a data frame that has 2 columns that are the same name, okay? So now I'm going to display this one, and we can see date 2 and this. And now what I'm going to do is I'm going to say data frame 3 is equal to a join of data frame 2 to 1 on date, drop date 2, okay? So if I run this, I'm going to get a new data frame. And then I say, hey, give me the first 5 rows. Okay, there's the data. When we talked about partitioning, we say RDD, resilient data set, how many partitions I have? I got 1, so I'm gonna write it. So now if I go ahead and I say repartition as 1, write to this path, it's gonna write out a file, okay? And then if I say, get me an LS of the file, and guess what? I got all this gobbledygook here. What does this mean? I don't know what it means. Well, the problem is that the way Spark works is it writes a bunch of files out. It doesn't write out a single one. It doesn't say, hey, write out temp.csv. And what it's going to do, it's going to write first a success. Then it's going to write a committed, a started always. Then anything that starts part start, that's your CSV file. Okay. And then after that, it says modification. So know what we want to do. I wrote this unwanted file cleanup and says, look at anything in temp, create from temp a directory, a file called temperature data CSV, and look for the extension CSV while doing this. Okay, so now what I'm gonna do is I'm gonna run this, and it's true. And now if I go ahead, and what it did is it just basically got rid of everything except that one file, renamed it to what I wanted, brought it up one directory, and now I see it as a CSV file. So it's a lot easier to work with and use with temperature.data CSV versus trying to say, hey, look at the part file, has some type of GUID in there, .csv, find it, and that's your file. Okay, how can we make this go faster? One of the things we can do is we can go ahead and use a schema. Okay, we can define a schema. Now we're going to redo this, but we're going to use a different data set. There's a data set called diamonds, okay? And diamonds is a data set that says, how can we predict the price of a ring if you're going to buy a ring for your wife, and what is the cost, okay? So what we're going to do is we're going to give it, this looks just like a SQL, in which we say, this is the first column, integer, so on, all the way down double. Here's the path, read in format CSV, header is true. Guess what? Use my schema and load it. Now we're going to get something that's typed. Okay, before we weren't getting things that were typed, but now we said, hey, first one's an integer, second one's a double, third one's a string, so on. So now it's typed. We can also display it. We can see here's the results. Say if we want to write this back out, we can write this a diamond temp. I'm going to write this time as a Parquet file, not a CSV file. Okay, so I'm going to write this back out. And last but not least, we're going to run the Parquet file on the cleanup. Similar thing, the only difference is extension. And if we run it, that should come back, okay? If we look at amazon.test 4K, we can see, okay, that there is a bunch of files here, okay? And what we can do is this is test information. We can read in the test, okay, information. So I'm gonna read it in right here. But now, guess what? It's a GZ Parquet, so it's zipped. So you're saving space, but you can read it in. And we can do the head of it, 500, we can see the data here. And we can see that the price is here, the brand. So we get some interesting stuff. This looks like a text field, okay? And what we can do is we can reduce the column. So say I wanted to do this, but I wanted to select only a few. Now I can say data frame 5 is equal to data frame 4, which is this one I brought in, right? Because just a read of the test data from Amazon. And I'm only interested in as in brand, price, and rating. Okay, so I'm gonna run, I'm wondering if I made sure, did I just run this day? 426. And again, if I skip the step, it's not bad, but if I skip an important step, it won't work. And now again, I'm gonna write it back out. Okay, and now I can convert it to a single Parquet and we can take a look at it and it should be fine. Okay, last but not least, we'll talk about TSV. So now we have our power plant. Okay, same thing, we're gonna load it. Okay, I gave it a specification, we can see right here. And then we can see the data file that came up there and we can write it out. Okay, and why I'm doing this is because what we're gonna do is we're gonna load each of these into a Hive database. And so I'm just preparing, okay? Okay, so now we did everything. So we did a bunch of files. We did Parquet, we did a gzip Parquet, we did CSV, we did TSV, okay? There's other files, Avro I talked about, CSV, JSON it works, Parquet, text, and JDBC. So any JDBC connector, it'll definitely be able to read and write data. So let's talk about data engineering. So we want to define load patterns, expose files as temporary views, transform files with Spark SQL, and review advanced Spark SQL statements, okay? So load patterns, I work with a client and we talk about how to load a database or a data lake. There's usually 2 patterns, 2.5, okay? First one's the full load pattern. Full load pattern's really easy. Guess what? Truncate the table, reload it. Very simple. If you're working with a data lake, delete the file, put a new file in. What is an incremental load? Incremental load is usually used not for small data sets like the one, but small to medium, I'm saying, because guess what? You get a file and you're appending to it, okay? Why do I say it's only small and medium size? Well, on large sides, you want to actually start using partitioning, okay? And again, just like databases, partitioning does work with Delta tables, okay? And it allows you, when you do those searches, to look for a subset of the files by directory, okay? PySpark. So let's talk about how we can start using our SQL skills, because that was the main thing at the top. I said, hey, you got SQL skills, you can use them, okay? Well, we want to create drop statements for a database table and views as supported by the Hive catalog. So those work, awesome. Spark.SQL, okay, allows the Python program to execute dynamic Spark SQL for select statements. This action returns a data frame. So if we ran it, we'd get a data frame we can read and write it. If we have existing data frame, we can say data frame, like I've read spark.read. I can say data frame.create or replace temporary view. And what it does, it takes the data frame and puts it into Hive as a session level view, and now you can query it. Last but not least, say if I had stuff, I just wanted to query what's in Hive, we do %SQL, and we can execute any commands right there, okay? Advanced topics, there's tons of Spark functions, too many to talk about. We're going to talk about data engineering with SQL right now. And I haven't heard any questions. Anybody have any questions? Everyone's still there?
Yeah,
Doug,
we're
still
here.
there? Okay,
We're here. Yeah.
I know there's a lot here, so I just wanted to make sure you're still there. Awesome. So what we're going to do is we're going to use temporary views. So we can add a new directory, process weather data using SQL, process loan data. Okay, so we're going to run this toolbox again. Okay, and what we can do is we can show the directories. And if we show these directories, right, LS bronze loan, Lake bronze, we can say we got the Amazon, we got the diamonds, we got loans, we got power, we got weather. So we got a bunch of stuff we can work with. Okay, so what we're going to do is we're going to say, hey, read in my weather. It's a CSV file, right? It's the one that we combined the two of them. So we're going to bring it in. And what I'm going to do is I'm going to create a view called, and this is low temps. Okay. And I'm going to show you how to do the same thing we did before, but we had to do fancy stuff to join it with data frames, right? I'm going to read in my high temperatures. Okay. And I'm going to convert that to a view. Okay. And now this is interactive SQL. So just right here, it's going to run a SQL statement. I say, take my temp view, H, L, join on dates. I want L.date as observation date, H.temperature as high temperature, low temperature. So if we run this, we're going to suddenly get a data frame. It's going to spit out, hey, there's my result. How do I make that? And what we do is we say, SQL statement equals a SQL statement I just tested. And I usually, when I develop, I'll do this temporarily, maybe in a notebook and then throw it away. Put it in a here document, anything with 3 quotes, and Unix is a here document, and that follows same with Python. So this is my SQL statement. I'm going to execute and become a data frame now. And once a data frame, what we do is we say path equal to bronze, weather, temp. I'm going to repetition it and write it out. So I'm going to write it out. And now we suddenly have a file. And if we clean it up like we've done in the past, and we say, is it there? It's going to show us that, yes, by the way, now we have a Parquet file there. Okay. Loan data, similar thing. We're going to have it in this directory. We're going to read it right up from the sample data directory. Okay. And what we're going to do is we're going to create a loan club view. Okay. Print schema, what does that do? It tells us what the schema is. So we can see that the first field ID is not a string and so on. And again, it inferred this because it's a CSV file. Okay. Last but not least, we select star from it, shows us, hey, here's the club data. Okay. And then this is something I do with other people in the past from when I was teaching similar one. This, we can clean it up, right? So there is things there's a ton of fields we don't want. One of the things we might want to do is infer, hey, if the loan status is current, then it's not a bad loan. False. Loan status is fully paid, then it's not a bad loan. Otherwise, bad loan. These are just basically doing some transitions and regex, replace statements to do cleanup. Basically, if we run it, we get a nice cleanup versus employee length and so on. Versus if we looked over here and we went to employee length, we have, see this, NA, 10 plus. Well, those are not numerics, but if we come here, what that algorithm did is it converted it into nice numerics. Okay. Last but not least, we can put it into a SQL statement and execute it to get our data frame. And we're going to do the same thing. We're going to write it out, and then we're going to clean it up as a single file so I can not guess at what the part is when I go ahead and try to publish it as a table. Okay. So I showed you some different ways, some complex SQL. Can even get more complex with rollups and CTEs, but really good example of what you can do. So tables instead of files, what does this mean? Okay. What I haven't done and talked about is the Delta file format. Okay, so Delta file format came out in 2018. Why is it really, really cool? Because it allows ACID transaction. Okay, so it gives you atomic, consistent, independent, and durable, just like a database. Okay, it allows you to do schema enforcement. Because it's keeping track of logs, you can do time travel as long as you don't vacuum. Vacuum means get rid of logs. Anything like I had, let's put myself in. Say John just joined a company and his salary, I'll make it easy, 50,000. Then he got a raise 3 months later, 55,000. Well, if I had 3 months of time travel, I'd see the 50 and 50,000, 5,000 as salaries. If I used a vacuum and it was recent, it would get rid of any deltas and show me the last one. It would be 55,000. Okay. Snapshot isolation. Problem is that if you're working with files and I read it, you read it, might be a contention, right? Delta file format, it knows how to handle that. Okay. And it's also open source. Okay. So Synapse is also using it. So this is just a thing of how does it work? Well, Delta file format is based on Parquet files and transaction logs. Okay. Exploring data sets with SQL. So this section we're going to present is designed to reinforce the fact that SQL skills applicable to PySpark. We'll be able to look at both simple and advanced constructs. Okay. And this is the last demo I have before closing up. So let's bring it up. So Workspace and use tables, not files. Okay. So what we want to do is we want to drop database if exists talks cascade. This is going to, right now I have a data and I got a talks. And if I go in talks, I got all those files that we talked about. Amazon products, Diamond Data, Loan Club, Power Plant, weather observations. If I go into weather observations, whoops, it said that I deleted it, so it's not reading it there. So that's what's wrong. So it's broken. So let's fix it. So let's go back to this. Now that usually happens when you're using something that is not based upon a Delta file format. It doesn't have that in Delta. So we're going to drop the database. Okay. Attach and run. Always forget that. And then what I'm going to do is I'm going to create a new database. So if we create it, now we go to data, we can see there is a talks, but no tables. Okay. Now there's different syntax. We see that in the bronze directory, we have 4 different types of files I want to post. So we can say create table, talks, Amazon, using Parquet, locations there, and we run this, brings a Parquet file in. Okay, we run this one and it brings another Parquet file in. It's the Loan Club, Parquet. Okay, Power Plant, Parquet. Weather file, Parquet. Okay, let's explore the tables. Okay, so what we can do is first we can say, hey, let's see the products, right? First 5, and we can see we have 5 products, and it gives some type of serial number, the brand, price, and a rating. Okay, we can also ask for the diamond information, right? So we can see that the cut, the clarity, the color, okay, the price, so on. Okay, and we can also look at the Loan Club data that's been cleaned up, and we have the employee length here, and last but not least, the power plant data. Okay, so what can we do? And weather observations, last but not least. So can we do some more advanced SQL? Let's talk about something that's really interesting. I want to look, okay, at the Loan Club data. I want to look for the addresses in Northeast. I want to show me bad loans, count by number of loans, and show me the average amount. Okay, so if I run this, okay, it's going to create it. Now I already graphed this, so this I can put back here. This is address state of a bad loan, number of loans, right? So let's look. If I go back here, I can see that it gave me this information, right? Now, if I go back and chart it, right? I thought it was a histogram. No, it was a bar chart, maybe. There we go. Now we can do it, and we can play with this. I could say, oh, I don't want number of loans. I want the average amount of loan here, and we could just easily bring that over. And now we get this. So if we apply this, and now we can see that we got average number of loans, and then we have false, average amount, true, meaning it's a bad loan. So, and if we didn't like that, we could get rid of this and say, okay, I just want to know the number of loans that are bad. And now we're back to, okay, these are my good loans, these are my bad loans, these are the states, and these are the number of loans, okay? So now I got that. If we look at this data, the problem is there's something called earliest year. And if we go back to the raw data right here, and if I find it, come on, doesn't like me. Where is it? I know it's in here. I'm doing demo. Okay, here we go. Earliest year. So it's a number. Well, that's not the year, like issue year. That's probably 2018 or 2005. Well, it's missing something, right? So we have to do some manipulation in the data. So what we can do is we can select from here earliest year. When it's less than 50, then add 2000 to it. Otherwise, it's greater than 50. It's probably 1900. So if we run this, okay, we can run this example right here. It's going to fix my loan year, okay? Now, let's say I wanted to fix my loan year and actually do something with it. So I want to now, so I got a CTE. I'm doing this here. Now I want to do, okay, I'm going to do running totals. So now what I want to do is I want to know row number over, petition by that state, then the loan year. Okay, and a fixed loan year. Okay, yeah. And then I want rows between unbounded preceding and current loans. So that's a running total. And I'm going to do a sum of it. Okay. So I'm going to run this again. Run cell. And now it gives me this data. And we can take a look at it, right? So I did year. So the running total by year. So Connecticut, 2011. So we got 40,000 is the first loan, 5,600 second. So 40,000, 5,600. And we can see it keeps on doing the run amount, right? And when 2011 goes over to 2012, it should transition stop back to the original amount for 2012. I went a little too fast right there. So we can see that the total loans for running total for 2011 is $797,150. And then it starts the totaling over again. So again, I can't show you everything you can do in Spark, but hopefully I've given you a really good introduction. Yes, you have to have this cluster running. So it's really important to do clusters. Last but not least, I will just go a little off script to show you something, right? I do have a job that runs every day. There's something called a job cluster. It spins up its own job, okay? And if we're interested, we can look at it, right? And we can see, hey, actually, go to job run, and we can actually see it'll pull up what ran. So I can see that hello world runs every day and it succeeded. Okay, so that's something called those automated jobs. Also on clusters, you can have 3 types of clusters. Okay, and I'll tell you the reasons why for each one. So a single node cluster, really good if you're doing, remember we said that if you run code that's not Spark dot, it runs at the executor node. Well, that's a really good use case for a single node. So now instead of having a cluster, you could run multiple single nodes and run that code. So if you had some way to partition it, it would work. Basically, a single node means that both the executor and the worker are just a single computer, and it's just knows it by how it's set up, okay? Standard, that's what we usually use. It's interactive. You can have it auto scale, okay? I suggest you do not auto scale it because it'll start with 2 and it can spin up to 8 depending upon load. But the problem is if you're doing streaming, sometimes it misses messages. So if not, you can get rid of auto scaling and it tells you, oh, I want 8 clusters worker nodes, 1 executes, 9 node cluster, boom, spin it up. How many VMs you have it? Well, I'm going to have a 4-core VM with 14 gigabytes of memory. What's most important when you do something like that is to terminate after. If you don't do that, guess what? You're going to have 9 different virtual machines with this much cost running continuously. Okay, so that's very important. Make sure that you go ahead and terminate after. Last but not least, why do we want to use high concurrency? Well, the high concurrency allows you to do something called table access controls. It's another talk I have. Hopefully Doug invites me back. And it's kind of just like SQL. It allows you to do the grants on the table level and the revokes, and basically allows you to secure your data lake, okay, using tables, okay, in Hive. So this is example 5, and then I'm going to summarize. So boom. So basically, all this is categorized on something that Microsoft calls the modern data platform or the modern data warehouse. You can look under their Azure architectural diagrams. You'll see it out there, okay? It comes from something called a spoken hub design, right? So you got source, right? Producers that are creating and either pushing or pulling data into data lake. Processing can be done on a subset to allow for investigational queries, okay? But you'll have a lot of data there. And data science models can be used to predict the future. So that's why people are going to data lake. The final curated data can be available to consumers, right? That curated zone or gold for analytic reports, okay? One of the things I found is really important when writing, stuff for a data lake is naming conventions, okay? for deployed objects, creating data lake entries, coding for data lake pipelines, data factory if you're using it to move data, especially if you're going from hybrid on-premise to the cloud. A lot of times data factory is used. Basically, these standards allow the end user to see, the code the same, the purpose. It's really easy to understand, right? The interesting thing about this talk is I talked specifically about Databricks. However, anything that has to do with Spark will work on any Apache Spark platform. So if someone comes to you and say, hey, you need to do something on Azure Synapse, it definitely works there, okay? So basically, if you learn a little Python and you know Spark, then it's transferable between the two products, and the future is bright for those who can adapt and learn. I've been doing this strictly for 2 years. There's a bunch of references there. Basically Databricks documentation, SQL functions, data frames, and the one article I did that kind of reinforces today's talk. So with that said, I'm going to pause, turn my screen on, and ask if there's any questions.
John, I have a question for you.
Sure.
At the beginning, I missed the beginning. I have to go back again because I had the other one in the triangle tonight. Talk about SQL data analysis. Talk about the particular SQL part. I was very, very interested. But anyhow, I was able to catch up your show for less hours. I cannot believe what you had done, Databricks. However, my question is, 6 months ago, I using Databricks community version. It's a free.
Yep.
Then I went to another program 6 months for data analyticals, and then I come back to data community version. They said, no, you got to give me credit. Do you know what was going on with them?
Yeah, unfortunately, I don't know. We're a Databricks partner, but we don't ever use the free version. So, it's just like Snowflake. Snowflake gives you free, or even Azure gives you free, and there's amount of, time and money. And if it expires, then you have to do a new one and sign up again. So that's the only thing I could say is, go ahead and re-sign up using a different name or, a different email address that might allow you to get in.
Yeah, I've been tried 3 times. So the Microsoft SQL is, I already suspended it anyway. You're already killing me. They already killed me. I signed it 3 times. I hope tonight it didn't burn your wallet. I mean, tonight's couple hours. I don't know how much costs your Databricks, unless you pay your own or companies. I don't know.
No, I'm lucky. I'm a
curiosity.
Microsoft MVP, so I get a bunch of free credits to burn. So yes, if we were
Really?
talking about Snowflake, then I would not have that. However, even with that free money, I'm very cautious about it. So remember I said that check that box. If an
Right.
inactive, shut it down. That's very important. Same thing with VMs. If you have VMs, there's a thing called auto shutdown. Definitely check it off and set it up. But yeah, I've been doing Databricks for probably almost 2 years, 2.5 years.
Wow.
And yeah, it's kept me really, really busy. So, and if you know SQL, you know Spark, you can be busy with Synapse, Databricks, and or any of the data warehousing platforms. There's plenty of work out there.
And second question, if I had a lot of jobs start interview for the position Databricks.
Yep.
I even don't know, I know a lot. I've done a couple of projects with the Databricks. How might I just don't know how I can have an interview to talk about Databricks. I don't know,
Yep.
you had some comments
So,
inside.
no, I would suggest, and again, this is not something I have done, but I've talked about it, I've written about it. So when someone comes to me and says, hey, do you know about Databricks? Be like, yeah, I've done like 15 different projects, and you want some sample code, we can talk and shoot the bull. A couple things. Let me see if I can find it to you and find it right this minute. So Amazon. I have this book, but it's downstairs. So I can't run because we're connected, but I want to show you a book to get and read. And I have it on my desk, and it's a really good reference book. It's kind of old, so it's not the newest thing out there, but it was done by one of the founders, okay? There was a couple guys that started off, and one of them's Matea Zaharai, and he was one of the guys that came out. It's an older book. It's Spark, the Definitive Guide, and it goes over that. It's well worth, you know, the $40 to have on your desktop, and it goes over a lot of tuning things that I didn't go over. There's just so much there, right? The RDDs, how to do low level stuff. It's all based upon Hadoop, right? Remember I said the way back is Hadoop, but it's really Hadoop in memory. And so you can take Hadoop programs and craft them to work on Spark.
Okay. Okay.
So that's the very first thing. The second thing I would look at is Databricks as a certification. So usually if we're looking for someone and they say, hey, I know Databricks, but I'm also certified. Well, it doesn't mean that you're an expert, but guess what? It means that you actually took, and again, this might not show up because I'm streaming at the same time. It's probably not going to show up, but there is 2 types of certifications. One's for like a developer on Spark, like Spark.read, Spark.write. Get certified,
Okay.
right? That way, when you're doing, I'm going to stop the share, but that way you get the interview and they say, hey, do you know it? Say, hey, I'm certified. And then right there tells them that you've learned enough that you passed the test. You know what I mean?
Wow. Oh, that's a great tips. Thank you.
You're welcome.
Thank you.
Welcome. And pleasure to meet you. And one of these days, Doug, we'll get together again. Hopefully I'll see you at PASS.
Yes, I'm hoping I can go if I can get the budget approved. So yeah.
Definitely.
Well, great. Any more last questions?
Yeah, so John, I have a question. This is Ravi.
Sure.
So the specific question on infrastructure of this Databricks, right? So we have cluster associated with our Databricks service. So for processing, so when job runs, we need to have separate cluster, and because, you know, sometimes we schedule the job and all that. So we have to have separate cluster for that. I mean, from architecture side point, what would you suggest to have 2 separate cluster, one for analysis people, where they can just go and check our Hive database and do analysis, and separate cluster for job? Or should we use only one cluster that can be accommodate both purpose?
Well, it depends how you're setting up your jobs, right? Remember I said that Azure Data Factory a lot of times is part of the solution, okay? In Azure Data Factory, there's a couple different settings you can set up. One is you can say create a new cluster. And if so, when it runs a job, it's going to create a new job cluster. And so if you have a cluster, say interactive, and that's what people do, when it runs, it creates a cluster. Now, one thing you have to be really careful of, okay? All these Azure subscriptions have quotas, okay? And a lot of times you'll run it, and guess what? If your quota is really low, like 10 virtual CPUs, and I initially using 8 for my interactive, and I run a job and I use another 8, guess what? You're 16, and your job's going to fail, and you're not going to have any reason why. And you start looking through the logs, and it's going to say, I can't, you know, instantiate cluster, because you know what it's trying to do? It's trying to launch those virtual machines, and each one of those virtual machines has CPU, and it goes against your quota, okay? So what you need to do is you need to talk to the person that runs that, and this will increase the quota. So that's one of the things I see with clients a lot of times, is that they'll have an interactive cluster and then they start running jobs and they fail and they don't understand why. And that's the main thing. But you can do like I showed you, like you can have a pool set up and you can have both your interactive and job clusters go against the pool. And that way you have something warm all the time to go against.
Oh, that's good. Okay, thanks.
You're welcome.
Anything else?
Good questions. Thank you for having me. I really appreciate it.
Yeah, this is great. Yeah, John, thank you so
Dennis.
much. Appreciate it.
No
This has been
problem.
Great. Like I said at the beginning, this has been recorded, so we'll get this posted. I'll send a link to John's, some of his references he had there, so you guys can download this stuff from GitHub. And other than that, this is great. I think it was a lot to work on and play with. So thank you again.
No problem. Thank you
Thanks,
for having
Doc.
me.
Thank you.
Great.
Thank you,
Have a
Doc.
nice night now.
See you, Denise.
Thank
Bye.
you.
Bye.
Bye-bye.